heart of urban power, driving AI, is beating strongly. Now is the time to apply cutting-edge fiber-optic DTS sensing technology. As modern power grids become denser and loads continue to rise, the core of asset management is shifting from electricity to heating. Other words, temperature monitoring. Today, I'll introduce DTS, a technology that uses a single fiber-optic line to continuously measure temperature across long distances and detect overheating risks at an early stage. Beyond simple detection, DTS also delivers value that connects to operational efficiency and asset management, along with a practical strategy for adoption. There are two major thermal weak points in power facilities. The first is underground utility tunnels and cable ducts, where local hotspots can occur at joints or damaged sections. Yet conventional detection methods often leave blind spots. The second is busbar systems, where overheating due to poor contact is a serious risk. But sensor installation and stable measurement are difficult. Because of high voltage and strong electromagnetic environments, DTS-based continuous monitoring is a leading solution that eliminates these blind spots. The key to DTS temperature measurement is Raman scattering. When a laser pulse is launched into the fiber, scattered light returns. Among the Stokes and anti-Stokes components, the anti-Stokes signal is especially sensitive to temperature. The system calculates absolute temperature using the ratio of these two signals, reducing errors caused by optical loss or external disturbances. As a result, it provides stable temperature data even across long distances. Knowing temperature alone is not enough. To respond immediately, we must know where the heat is. DTS applies the OTDR principle by measuring the time of flight of the backscattered signal and converting it into distance to determine location. While conventional methods often identify only broad zones of tens of meters, DTS can pinpoint local hotspots with a fine spatial resolution of around 1 meter, significantly reducing blind spots. A DTS system consists of 3 parts. First, the DTS interrogator, which includes the laser, detector, and signal processing. Second, the sensing fiber and its protective structure installed in the field. And third, visualization software that displays temperature profiles like a map and supports alarms, trend history analysis, and SCADA integration. Recently, both long-range single-channel models, capable of monitoring tens of kilometers, and high-speed models with sub-second sampling are being widely adopted. In utility tunnels and underground transmission lines, DTS provides 2 key values. One is early detection of fire and abnormal overheating. It continuously monitors along cable trays and immediately reports abnormal temperature and location. The other is load optimization based on RTTR. By reflecting the actual thermal condition of the cable, RTTR calculates the safe operating capacity, improving asset utilization and enabling more precise operational decision-making. The advantages of DTS in utility tunnel monitoring can be summarized in 3 points. First, continuous monitoring across the entire route eliminates blind spots and prevents missed risks. Second, instead of relying only on fixed thresholds, it analyzes temperature rise rates to detect early anomalies faster. Third, it provides accurate location information down to a specific meter point, which accelerates dispatch and inspection and enables smart integration with ventilation and fire protection systems. RTTR goes beyond the limits of static ratings. Traditional ratings are conservative because they assume worst-case conditions, which prevents full utilization of assets. RTTR collects real-time cable surface temperature via DTS and uses internationally standardized thermal models to calculate conductor temperature and remaining capacity for operators. This enables safe temporary overload operation in emergencies and can increase transmission capacity by roughly 10 to 30%, depending on conditions. As a domestic example, a KEPCO project has introduced a composite protection system that combines DTS with DAS to monitor not only temperature anomalies, but also external impacts and vibration. From an ecosystem perspective, major Korean cable and construction companies are also expanding into solutions such as cable, spectral monitoring, and joint monitoring, strengthening competitiveness. The message is clear. Power grid protection is evolving from a single sensor into an integrated monitoring system. Busbar overheating typically starts at connection points. If bolts loosen due to poor workmanship or vibration and oxide films form, contact resistance increases. Then heat generation rises according to PIR, and the higher temperature accelerates further, degradation eventually leading to thermal runaway. The challenge is that electrical sensors can malfunction in environments with strong electromagnetic noise. Because fiber optics are dielectric, DTS is largely immune to EMI and enables stable monitoring. In Busbar monitoring, DTS stands out for installation, flexibility, and hotspot-focused measurement. It can be routed to wraparound high-risk connection points to directly track temperature, and it can provide continuous monitoring even inside enclosed structures. Newer designs also include structures such as O-ring integrated sensors around bolts, with the goal of clearly identifying exactly where the problem is. The resulting data supports preventive maintenance CBM, reducing overall inspections and lowering costs through targeted repairs. When comparing DTS with linear heat detection LHD, the direction is fundamentally different. LHD is mainly for fire detection and triggers only when a set temperature is reached, so the data is limited. DTS provides real-time temperature distribution and trend analysis, enabling early anomaly detection and higher location accuracy. It also offers advantages in maintainability and reusability, and its use extends beyond fire detection to RTTR and asset management. In short, DTS is not a passive safety device. It is an active asset management tool. Compared with thermal cameras, thermography typically checks only visible areas on a periodic basis. It has limitations inside switchgear or in hidden sections, and anomalies may be missed during the gap between inspections. DTS eliminates those gaps with 247, continuous monitoring, and directly measures areas that thermal cameras struggle to see, such as inside cable trays or enclosed structures. From a preventive perspective, DTS enables more consistent data-driven operations. With point sensors, installation points increase, wiring and labor dramatically, making sites complex. FPG sensors are precise, but as the number of points grows, sensor cost rises and long-distance scalability can become burdensome. DTS, however, uses a single standard telecom fiber to cover wide areas, offering strong economics for large-scale monitoring. In other words, the more you cover, the better the economics. This is DTS's key differentiator. The business case can be explained in 3 parts. First, by improving utilization through RTTR expansion, can be delayed, deferring CAPEX. Second, it reduces outage time by quickly identifying fault locations and cuts unnecessary inspections, lowering OPEX. Third, the largest value is avoiding the risk cost of major incidents, such as fires and blackouts. Ultimately, DTS should be viewed not as an expense, but as an investment that improves safety and operational efficiency at the same time. For reliable implementation, standards-based design is essential. Cable ampacity and thermal modeling. Follow IEC standards and performance requirements and test procedures for temperature. Monitoring systems can reference IEE guidelines. In Korea, fire safety trends increasingly emphasize detection systems that can identify exact locations. In short, DTS gains trust in the field when it is designed as a full package, aligned with standards and regulations, not just as a standalone technology. A customer decision guide can be summarized in 3 sentences. First, DTS eliminates blind spots. Second, it is inherently stable because it is fiber-optic based and remains strong even in EMI environments. Third, it accumulates data and expands into asset management and operational optimization. DTS is ideal for new installations, but a phased rollout starting with aging sections or high-risk joints can also be highly effective. Over the long term, DTS becomes foundational data for a digital power grid. A comparison table for utility tunnel monitoring shows that DTS offers long coverage, high location accuracy, and analytics-based alarms such as temperature, rise rate detection. LHD is structurally simple but limited to zone-level detection, and point sensors are precise, but can be burdensome to deploy and maintain at scale. Considering EMI immunity, maintainability, and application scope, DTS emerges as the most advantageous overall choice, especially because it supports not only fire detection, but also RTTR and asset management. In a busbar monitoring comparison, DTS is evaluated alongside thermography and wireless temperature sensors. Thermography is mainly for visible areas and periodic checks, Wireless sensors are fast to install but have limitations related to communications, power, EMI variables, and point scalability. DTS, when properly designed, can continuously monitor, including connection points, and offers strong reliability and scalability. The conclusion is that continuous, data-driven monitoring is the key to Busbar safety, not one-time inspections. Finally, the key message is this: adopting DTS reduces cost and increases value. RTTR delays CapEx, faster fault response, and reduced inspections lower OpEx, and most importantly, major risk is reduced to improve safety. DTS is not just a sensor, it is the starting point of digital transformation that embeds a nervous system into power infrastructure, enabling assets to sense and respond to their condition in real time. Accident prevention isn't a cost, it's loss prevention. The reliability of the national power grid begins with temperature. Make power infrastructure safer and smarter. DTS is the nervous system of power infrastructure. NWC will safeguard the AI era,